Welcome back to my tutorial series on how to make a game using Flutter and Flame. In this episode, we're finally adding in traps, which will give our player a little bit more challenge and something to avoid, because if he doesn't avoid it, well, he's gonna have to respawn. We have a lot to do, so let's get started. To get started, we're going to open up our level in tiled because we need to put in the spots that we want our saws to spawn. We're going to add 2 saws so I can show you how to make it do vertical and horizontal. So to do that, we're going to go to our spawn points layer, come over here and click the insert rectangle. And for our saws, we just need to make sure that it takes up 2 squares because that is kind of the size of our saws. They are a little bit bigger, so we need to make sure that they're at least 32 by 32. We're going to just drag out a section right here because I want my saw to kind of be half visible and half in the ground. If it's going across an object, then I'm going to put it in half of the ground. So that's a good way to do that. So for our saw, we can come over here to the properties of what we just created, and we can give it a class of saw and hit enter, and we need to give it some custom properties. So the first custom property, which we can do by clicking the plus sign, the first custom property we're going to add is going to be a boolean, because we're going to have a saw that can go horizontally, and we're also going to have a saw that can go vertically. So we need to see, is this one that goes vertical or is this one that goes horizontal? So we can do that very easily by just having a bool, because we only have 2 options, vertical or horizontal, and so we can use that with true or false. So since we want to check to see if it's vertical, we can just write is vertical is the name of our boolean. And then if it's not checked, we know in our code that that can be horizontal. And if it is checked, then it's going to be vertical. We also need to tell it how we want our saw to move. Like, for example, the saw is going to spawn right here, but I want it to be able to move a certain distance either to the left or to the right, or if it's vertical, to the top and to the bottom. And we can do this by adding another custom property. And this one is going to be a float. It's kind of like a double in Dart. A float is just, it has a decimal. So we're going to make it a float, and then we can call this offset negative. So I'll just write off neg, capital N. And then this is going to be for the negative, which if we're going horizontally is going to be the left, because negative is left. And if it's vertically, it's going to be up, because up is negative. And then we can also make one more float, and this one is just going to be off positive or off POS. And then this is going to be for the positive. Now, there's a lot of ways that we could calculate how we want our saws to be able to move at what distance, but the easiest way, I feel, is we can just count how many squares we want it to move from where it started. So right here, if we select our object, I want it to go the whole way to the left till it hits this block, so we can just count the squares, 1, 2, 3, 4, 5, 6, 7, 8, and then for our off neg, it's going to be 8. And then if we want to do the same for a positive, we can do 1, 2, 3, 4, 5, 6, 7. The off positive is going to be 7. Perfect. Now we can actually select this and copy it, and now we can put, we can select this and copy it, and now we can Control V and put another saw right in this location. So we want to make sure that we change this as well. It is going to be vertical this time, so we can check the is vertical, and then we want it to be able to go up 1, 2, 3, 4. So the off neg is going to be 4, and then 1, 2, 3, the off pos is going to be 3. And that's essentially saying we're going to be able to go up 4 and down 3 from where we started, which makes it very easy to keep track of your code. We might run into issues later, which is why it's a float. Maybe you need it to move just not the whole block, which you can do that, which is why we made it a float. So yeah, we can save this, and now we can go back into our code. And now what we need to do is we need to start creating our, well, we need to start spawning in our saws. So to do this, we already have a section here where we're spawning objects, so you kind of already know what we need to do. I did make a mistake in the last video where we did the fruit. I forgot to add a break in here, so just make sure you add a break right under where we add the fruit. And now what we can do is we can do another case. This will be case, and then we just need to look for a saw, and then we can make sure that we break this time. There we go. And now we just need to grab a reference to the saw. Well, this is very straightforward. We can just do like we have been doing. So first what we're going to do is final sol, and then sol is going to be equal to, well, class of sol, which we don't have yet. So we can go into our components and make a new file, and we'll call this sol.dart. And inside our sol.dart file, we need to make a class, and this class is going to be class sol, and it's going to extend, and it's going to extend a sprite animation component, just like we did before. So we can do sprites animation components. We can select it from this one. And then we need to pass in what we normally do when we're spawning stuff. We need to pass in some parameters, which is going to be the position and the size. So we can do that by doing sol, and then we can do in brackets, this way they're named, and we have to give it a name first. So we can do position and size, and then we don't actually need reference to the position. I mean, we might need reference to the position and the size, but what we want to do is make sure that we just pass that on to our super, which is the sprite animation component. So we can call super, and then the super is going to take a position, which is our position, and a size, which is our size. I'm going a little bit faster here because we've done this enough, and you should hopefully know how to do that. So we're going to pass that in. Now, if we were to call this, we would get an error because we do need to pass in a sprite to our sprite animation component, or an animation to our sprite animation component. So we can call our onload event, and we need to pass in the animation, and we can do that by doing animation equals. Obviously, we're going to need to create an animation for our sprite, so we can do sprite animation, and we already done this before. It's dot from frame data, so we just need to pass in the frame data. We're going to need an image, which we know anytime we need an image, what do we have to do? Get a reference to our game, so we can come up and do with has game ref, and then pixel adventure, and hopefully this is starting to make sense, because again, there's a few things we need to do different, but once we start doing them, they all kind of work the same. Every sprite animation component, you're going to start doing it this way, so hopefully that makes sense. And then for our image, we now have reference to our game, so we can do game.images.from cache, and then we need to pass in the path to our sol image. So our sol image is assets, images, traps, and then sol. So we can do that. We can do traps sol, and then we need to use this one right here, which is on 38. So capital O-N. Let me make sure that wraps 38 by 38 .png. So that's the image that we're passing in, and then you can open that up. This is what it looks like. And then we need to do our actual data. So we can do a sprite animation data.sequenced, because it's a strip, so it's just a whole line, and we can just do a line there. So we do need to pass in the amount, the step time, and the texture size. Well, the amount, we can go and open up the image, and it's 368, so the amount is 8. The step time is how often we want it to animate. Now, on our other animations, it was 0.05, but what we can do here is this is going to make this all look faster. So we can do static const, and then we can do a double, and then this double is going to be a we can just we can call it we can just call it step time. Just know that step time is equal to how fast it animates, and then we can actually make it a little bit faster. We can mess around with this code, and we'll make it 0.3, and we'll see if that's fast enough. If not, we can bump that up or down or anything. And then for the texture size, we already know the texture size is 38 by 38, so we can do vector2.all 38. Cool. Now we're going to get an error if we implement this. So before we forget, like I always forget, because we're using something else, we need to go to our pubspec YAML, and we need to import our new traps. So we can do assets, images, traps, and then instead of fruits, we're going to do sol. And I realized that I wasn't showing the keyboard shortcuts, so I got that by doing selecting it, and then Alt-Shift down duplicates a line, in case you don't know how to do that by now. Sorry about that. Cool. So we can save it, and then we can hit Control W. And now we should have access to this image without getting any error. Now that we've created our sol, what we can do is we can go back into our level.dart, and now we can actually pass in our sol class that we made. So we can do equals sol and then sol, and then we just need to pass in pretty much the same thing we do for the fruit. So position and then size. So we can just save ourselves some time and copy that. And then we of course need to add the sol. And if we save and refresh, we should see our sols. Perfect. Now our sols are moving really, really slow, so we don't want that. We definitely do want to speed this up. Instead of a step time being 0.3, we can make it, let's see here, is it 0.5? No, let's try 0.1. All right, that's making it a little bit faster. Let's try 0.03. I think is going to be a super, there we go. Now our sols are spinning. Cool. Now with our sol right here, we don't want it above the background, right? We want it behind the background. So what we can do is on our onload, we can just pass in priority and then make it -1. We've been making a lot of things -1, our fruits -1, etc. If you find that it's not overlapping how you want, you can give these other numbers. The smaller the number or more negative the number, the further back it'll be, and then the higher the number, the closer it'll be to us, essentially. So if I'm putting everything in -1, because if it's all -1, then it'll go in the order that it was added. Fruits are added first, so they'll be behind the sols, etc. But if you ever feel like, hey, my sol should be in front of the stuff, not behind it, then you can tweak the priorities of the stuff. I didn't mention that in the fruits, but that's what that does. So cool. So now our sols are behind that, and they're moving quite nicely. But we want to be able to actually move our sols, so we can start doing that as well. To be able to move our sols, we want to be able to know where we're going to move them to, because we want them to go there and then go the other way. So what we can do is we can start passing in the other information that we have as custom properties. So for this, we can do final bool. Don't make it final if you plan on changing it, but we're not going to, at least in this tutorial. So is vertical is going to be the same, but it could be something where maybe it will change halfway through or something like that, so that the stuff can change. But for us, it's always going to either be horizontal or vertical. We can also grab in our double, which again in tiled is a float, but it's the same thing. So doubled off neg, and then final double off positive or pos. And then we can just bring these in. This dot vertical by default is false, and then this dot off neg is 0, and then I keep doing semicolons, and then this off positive equals 0, and then comma. Cool. So now we can actually pass this information in. If we don't pass it in, it's going to default to this stuff, but we do want to pass them in. So let's go ahead and go back to our level so we can do that. So with our level, we just need to get access to our properties, so we can actually do that real quick by doing final is vertical equal, and then is vertical is equal to spawn point dot properties. So in the past we had to grab the actual layer, but once we grab an actual item, we can actually grab the properties from that as well, which is really cool. And that's how you grab the properties. So before we did the entire layer, like with our background, but now we can just grab the actual item and call dot properties on it. And then we just want to get the value, just like we did for our background. So we just want to get the value of is vertical. And then we can actually duplicate these, Alt Shift down twice, and then we can do we can actually Control D, highlight is vertical. Control D will highlight it as many times as you want. I just want it once, and then we can just do off neg, and then the same again. Control D. Now we've selected both is vertical, and then we can do off pause. Just a quick way to replace stuff. And now we can just pass those in. So is vertical is vertical. That's why I like naming the stuff the same. So off neg is off neg, and then off pause is off pause. Off pause. There we go. So we're essentially grabbing the value of is vertical, off neg, and off pause, and then we're passing in is vertical to is vertical, off neg to off neg, off pause to off pause, and now we actually have reference to it. If we refresh, nothing should be broken. Perfect. But now we can go back into our sol and we can start using the speed. And just for the step time, just because, I mean, I know that it's animation, I'm just going to call it sol speed. So you really know that this is how fast the sol will move. And you can change it with will. But that way, if you want it to go faster, you know to change the number. Cool. And then what we need to do now is we can actually grab in some other constants or variables, and we'll do static const move speed. This is going to be how fast our sol moves. I'm going to give it a size of 50. I think that's pretty good, but we can change it. And then we also need to get reference to our tile size of our map itself. So we're just going to hard code this in here, 16. We might even have this somewhere else in our game that we could probably reference it. But we're just going to hard code it 16. That's how many in our tiled. Each section is 16. So we're going to multiply the numbers that we've given it by 16 to actually get the actual distance. So we do want to do that then. And then we are going to pass in a few other things. So we'll just do them now. We want to move direction. By default, it's going to be 1, which means it's going to go to the right because we're either going to be 1 or -1. So the move direction is going to be positive. So it's going to be a 1. And then we just need another double here. And we can call this whatever we want. We'll just call it range neg is equal to 0 by default, and then a double range positive equals 0. And this is essentially we're going to take the off neg and the off pause, multiply it by 16, and then consider that as our range of how far we can go then. We could also maybe use that later, say don't, choose a random number in this range and go that far, but we're not going to do that for now. Cool. So now what we need to do, now we've set up our variables, we actually need to go and actually do what I just said. First, we need to get access to the actual range that our player or that our sols can move to. So we can actually do this right under our priority. So what we can do, it's going to be different depending on if it's vertical or not. So we need to check to see if it's vertical or not. So we can do if vertical, which means we're going up and down. Well, our range negative is equal to our position.y, which if we're going vertical is the top of our sol. And then we're going to subtract, because we're going negative goes up. We're going to subtract the off neg, which is the amount of squares that we've counted, times our tile size. So I'm hoping this makes sense, but we're choosing a range, which is going to be from the top of our player to as far as we want it to be able to go. And that is going to start at the top of our player. We're going to subtract the amount of blocks times our tile size, which in this scenario is right here. We're going to essentially start right here at the top of our sol, and then we're going to go to the top of here, which is where I chose. If you look in the design, the amount of squares would put us right here. Hopefully that makes sense. And then we would do the same for the range pause. It's equal to our position.y, which is the top of our player. And then we're going to offset the position by the off pause times tile size. Now, one thing you might think here is, why wouldn't we get the position.y plus the height, which is the bottom of our player, right? Normally you would want to get the width, the width or the bottom of your player and then add to it, but we want our, you'll see it when we actually implement it, but we want it to stop at the same spot, right? So we don't need to really pass in the width of our object or our sol, because if we're only going to always go from the top or the left, it's always going to not factor in the width in our math. Therefore, it's always going to be the same spot, right? Because it's going to end like right here, and then our sol width is still going to be where we want it. So I just wanted to call that out. I was coding it. It was like, why won't I do the width? Oh, well, I don't have to. As long as I don't add the width, I don't have to factor in the width, because it just factors itself, because it's still going to be at the same spot. So I just wanted to make that abundantly clear, especially when we did a lot of the width and stuff like that with our player. Cool. So if it's not vertical, then we just need to do the horizontal, and we can make the range neg equal to position dot x, which is our horizontal, minus, because we're going to the left, off neg times tile size, and then again, range pos is essentially the same, position dot x plus, because we're going to the right, off pos times tile size. So hopefully that makes sense. For the horizontal, we're taking the position of our x, which is right here, subtracting the amount of squares times tile size, which would put us right here. Perfect. And then if we're going positive, we're still checking the left side of our saw, but we're going to add the amount of squares we need to, which will end up here, and then it'll make it still go here. Cool. So now that we have access to the range neg, the positive, what we need to do, and the move direction, now what we can do is we can come down out of our onload and we can just do an update function. The update function is actually very simple. Anytime that we want to move something, we can just change the position. So if we just did position.x plus equals, and then we would just need move direction times move speed times delta time. So we're going to, every frame, we're going to update our position.x by the move direction, which in this case is 1 because we're going to the right, times our move speed times delta time. And if we refresh this, well, both of our saw, I didn't have to refresh it, it's an update function, but both of our saws are now moving off the screen. Well, obviously we don't want that for one of our saws because one of them is vertical, and then we also want to have it stop. So instead of just updating it right here, we can cut that. What we can do is we can check if it's vertical, because if it is vertical, we want to handle it, instead of going left and right, we want it to go up and down. So we can actually create a method here called move vertically, and then pass in our delta time, and then hit control period to create a method. And then if we're not vertical, we can do else, and then we want to move horizontally, pass in our delta time, and then control period to create a method. So now we can break these out based on if we're a vertical saw or a horizontal saw. So for our vertical saw, well, we want to increase the position on our vertical. So if we do position.y plus equals move direction times move speed times delta time, well, now our saw is going to come down because it's going to keep increasing and increasing. And then we can actually do the same for our move horizontal, just make sure it's on our X. So we're good there. Perfect. Now our saw is coming down and our bottom saw is going to the right. However, we want to flip the direction, the move direction, depending on if we've gotten to our range positions. So what we can do now is right before we actually apply the movement, we can check if our position.y is greater than or equal to our range positive, which means we've met the positive range. Then we can just do move direction equals -1, because the move direction negative will just say, hey, let's go the other way, right? So if it's going positive and it's gone so positive that it's gone past where we are allowed to go, then it's just going to change the move direction to -1, which is just going to make it negative, and it's going to go the other way. And then of course we need to do the opposite. So else if our position.y is less than or equal to our range negative, which means we've gone too far negative, then we can just switch the move direction to 1. And then if we save and refresh that, our saw will go to exactly where we said it can. And now you can see our vertical saw is going back and forth, and it's never going to go further than it's supposed to, and it's going to just loop back and repeat itself, which is awesome. So now we just need to do the same for our move horizontally. I bet you that you know exactly how to do this, but we can do position.x is greater than equal to offset pos. Perfect. If it is, well, we just want to switch the move direction to equal -1. Else, we need to check to see if the position.x is less than equal to our range neg. Don't do off pos, do range pos. See, I was just tricking you there. Downside to different names, you get a little confused. Move direction equals 1. And if we save and refresh this, our saws, yes, our vertical and our horizontal saws are now going to their spots, which is awesome. We now have saws in our game. However, when we hit the saw, well, nothing happens. Nothing happens for 2 reasons. 1, we haven't coded anything to happen. And 2, there's actually no collisions on our saw. So even if we did code something to happen, it wouldn't have any. So let's go ahead and do that first. We can actually do that by coming up to our onload right below the priority. We actually just need to add a circle hitbox. Now you can customize this circle hitbox however you want, but we get lucky here because of how we've set everything up. If we actually turn the debug mode to true and refresh, the circle hitbox is actually the size of our saw. So we got lucky there. If, however, the hitbox needs to be different, then that's when you would change it like we did with the fruit or we done with our player. But for the saw, we don't actually have to change that at all. We can just add it and it just works like we want it to, which is really great. So now that we have collision on our saws are working properly, we need to actually handle that collision because we are colliding with this. We just don't know that yet because we haven't told our game to handle that collision. So to do that, we can go to our player.dart and we can actually handle that collision. So let's think about what we want to happen when we collide with a saw. So the end goal of what we want to happen is we want to respawn to where we started, and so we can do that again. So what we want to do just from the very beginning is we want to get a reference to where we started. If we refresh the game, we're starting right here, but we don't actually have an actual reference to that other than our player's position and size. However, as soon as our player moves, that position and size is going to be different. So what we can do is we can get a reference to our starting position by calling vector, by making a vector2 called starting position, and then it can be equal by default to a 0. But then as soon as our player, will go down to our onload event, as soon as our player spawns in, what we can do is we can set that starting position. So we can do starting position is equal to a vector2, and it's going to be the position.x and the position.y that we spawned in. So as soon as we add our player, it's giving a position and what's actually given a position and a size, but we don't need the size. We know our size, but it is giving a position of an x and a y, and we have a reference to that only for that split second when our player is added. At that point, if we move or anything like that, it's different. So we can just grab a reference to that right here, set it to our starting position, and now we know where we started before we moved, which is very handy because we're going to need to use that later on. So now that we've done that, well, we have collision with our saw, so we can actually detect that collision by coming down to our on collision. Just like we did with the fruit, we can do if other, which is what we're colliding with, is saw, which is what we've created. Make sure you import it. Then we need to pass in what we want to do. Well, if we hit a saw, we want to essentially respawn. So we can actually just call a method to keep our code nice and clean. We can just call respawn. And then we can hit control period to create a method. So with our respawn, we can actually see that in action. When we call respawn, let's just say that our position is equal to our starting position, right? So that's essentially what we want to do. We want to make it look fancier than what you're about to see, but that's what we want to do. So if we hit this, oh, there we go. We go right back to our starting position. Fantastic. However, even though this is what we want to happen, this is not that beautiful, right? We don't know what happened. Why am I back at the start? Well, you hit a saw and you actually had to respawn, but we didn't tell you that, right? So we need to take some extra time here to make this and also fix that, but make this look nice and clean. So let's go ahead and do that. So what do we want to do? Well, we have animations that we can call when we get hit. So let's go ahead and create our hit animation. How do we do animations? Hopefully you know by now, but if not, we're going to come up to our player state. We're going to call hit because our player got hit. We're then going to Alt-Shift down on our sprite animation section, call hit animation. We're then going to scroll down until we see where we're creating our animations. Alt-Shift down. Now we can say hit animation. And then this one is hit. And then we need to see how many frames are in our hit animation. So main characters, mask dude, hit is 1, 2, 3, 4, 5, 6, 7. So we have 7 animations. So we can pass that in. And then we also need to make sure that we add it to our animations. Player state hit equals hit animation. So we've saved our animation. We can refresh to make sure we have reference to that. And now when we respawn, instead of setting our position, which this is our end goal, but we're going to comment that out for now, what we can do is we can just pass in our animation. So we can do current animation. Current is equal to player state dot hit. Right? And now if we get hit, well, now our animation is playing. However, it's not playing how we want it to play, right? So, and the reason why is because we're consistently colliding with our saw. So at that point, it's going to consistently say, you're getting hit, you're getting hit, you're getting hit, you're getting hit. So what we want to do here is we want to actually create a Boolean to check to see if we've gotten hit or not. If we've gotten hit, then we don't want to do anything until we're done doing what we want to do. So we can come up here, find out wherever I have some Booleans. We can do bool got hit, kind of like got milk, right? Got hit. And now what we want to do is we want to set got hit to true. So we can actually do that right now. We can do got hit equals true. Now, if got hit is true, what do we want to happen? Well, for our player, we want nothing to happen. We don't want our player to have collision. We don't want it to have velocity. We don't want anything to happen. So what we can do is up here in our, let's go up here to our update function. Where's our update function? Gets a little confusing here. There we go. So here's our update function. So what we want to do inside of our update function is we can actually check to see if not got hit, right? So if not, exclamation point, got hit. So as long as we have not gotten hit, then we want to do this stuff. This way, if we have gotten hit, we don't want to do any of this stuff until we're not hit anymore, right? So we can select all of them, Alt, and then push up on the arrow, and then that can actually put us in. That's how you move a bunch of stuff. Alt-Shift duplicates it and moves it. Alt up or down just moves it up or down. But now when we save, if we get hit here, we can refresh and get hit, well, nothing happens. Our player freezes. I can't move, nothing like that. And as you saw, it's not repeating and repeating and repeating and repeating because we're not being able to check any more collisions. We're not checking collision anymore. All of that stuff has stopped until we say to continue. We're not updating our player state over and over again. We're not changing any of that. So, well, there's probably still collision, but we're not updating our player state to affect that collision is what I meant to say. Because yeah, we're probably still colliding when this comes back. So cool. So now that we've stopped everything from updating, we can come back to our respawn and we can continue on. So, well, what do we want to do now that we've gotten hit? Well, first what we want to do is we want to wait until our hit has finished its animation, because this is looping. We want it to only loop through once, and there's not a way to just loop through once. Please let me know if there is, but I haven't found a way to only loop through an animation once and then do something else. So what we can do is we can just count that ourselves by creating a duration. So we can actually do const hit duration is going to be equal to duration, and then we can give it milliseconds. Now we know that in the code, we the milliseconds for our step time for our players' animations are 50 milliseconds. And we know that our hit animation is 7 frames. So we could technically do 50 times 7, which is 50 milliseconds per frame, 7 frames. But you won't know what this code is, so we can just do 350. But that's where I came up with 350. I wanted to explain that. It's 50 milliseconds per frame, and there's 7 frames. 50 times 7, 350. Cool. So now what we can do is we can actually delay our code by calling a future. And we can do future.delayed, and it's going to take in a hit duration, which we've created. And then we have another parameter where we can delay the code a certain amount of time and then run a function after that. So we can do the brackets, the parentheses, and then the brackets. So future.delayed is going to wait this amount of time, which is 350 milliseconds. And then when it's done, it's going to run this function. So with this function, now that we've hit our player, we want to move our player to the starting position. So we can do this by doing position equals starting position. Now, if we save this and reload, and now our player goes and gets hits, he should show his animation and then move. However, his animation doesn't stop. We're still going back to continuing looping what our last animation was. That's okay. We're going to fix that, but we are able to move our player to where we want it to be. However, there's also an issue, and we already knew that this is going to be an issue. When we come from the left, our player is going to move to the correct position based on the left. So the easiest way to fix this is set our scale to equal 1. That way it's always scale.x. Make sure our scale.x is equal to 1, so that way we're always going to be facing the right, and we don't have to offset if we were going to the left and hit and all that. We can just always switch our scale.x to be positive. That way it's always going to make our player look like this. And then even when we come from the left, our player is still going to hit from the left, but then switch to the right when we move it. Cool. Now we actually have another animation that we want to call before we actually put our player here. And it's actually in, if we scroll up here, it's in our main characters this time, and it's called appearing, and it has 7 frames as well. It is, however, special because it's bigger and it's in a different location. So what we can do is we can come back up to our player state. We want to make another animation or another state called appearing, and then we can do our animations like we've done before. So sprite animation, appearing animation. Perfect. Scroll down until you see us making it. But here what we want to do is we don't want to use the default sprite animation that we've made before, because I've hard-coded the path, I've also hard-coded the size, and I've also hard-coded the texture size as well. I could take the time to make this more dynamic, but then I'm going to have to update all of this and all of that, and it's just, I don't have to do that. So for the appearing, and if we ever use the disappearing, which we probably will, probably in our next video, I want to add when we get to the end of the level and go to the next level, we're going to use that. We can just write a little bit extra code now and save ourselves some hassle later, especially because it's just copy and paste. So we can copy and paste this, and instead of sprite animation, we're going to do special sprite animation. So for our appearing and our disappearing, we're going to call special sprite animation because it's special. Otherwise, we're just going to call the normal sprite animations because they're all in the same folder. Hopefully that makes sense. So we do need to change the from cache. So we're no longer doing main characters, character, and then state. We're actually just doing main characters and then state. And then both of our appearing and disappearing is 96. So for now, again, you can make this dynamic, but for now, we'll just do 96 by 96. And then for the vector.all, because it's 96, we just want to make sure that it's 96. Now, before we do anything, we want to go to our pubspec YAML and make sure we grab in that folder as well. So select the main character's mass dude and Alt-Shift down, and then just make sure that we bring in our characters folder directly and not anything else. Cool. Control W. So now we have access to the special sprite animation. For our hit animation, we can copy that and then do appearing animation. And then this one is going to be special sprite animation. And then we're going to pass in appearing, and 7 is fine as well. And then for our player hits, we're going to, instead of doing a hit, we'll do appearing and then appearing animation. Again, pretty much the exact same way, but we're just handling the appearing a little bit special, which is why I called it special. But you could technically recode all of this, but we're too far deep. This was much, much quicker, but feel free to recode this if you want to. That's up to you. So now instead of having our animation, right, we're in our current equals player hits. What we want to do is we want to move our player we want to set the scale X to be positive. We want to move our player to the starting position, and then we want to use our new animation called current equals, and then it's player state dot appearing, right? So we're going to wait till we get hit. We're then going to switch our scale to positive, switch to our starting position, and then switch our animation to our current animation to appearing. And if we save and refresh this, we are going to get a slight issue, but it is going to start playing the appearing animation. Perfect. However, it doesn't play you in the right spot. And the reason why it doesn't play you in the right spot is because our player sprite animation is 32 by 32. Our appearing animation is 96 by 96. So what we need to do is we need to, while we're playing our appearing animation, we need to use our starting position, but we need to offset it by a certain amount because of what we're doing. So we can do vector minus vector2.all, and we need to factor in what is our sprite animation. I said 32, it's actually 64 compared to what it is. So it's 96 for our appearing animation, which again, if you don't know, 96. And for our sprite animation for a player, it's 64. So we need to subtract 96 minus 64. Again, I'm going to delete the math, but that's what we're doing, which is 32, right? So we just need to offset, we need to subtract 32 by 32 because we have to offset the difference from the animations. So if we get hit now, it moves our player exactly where we want. Perfect. However, we don't want this to loop either. So we already know what we need to do. Hopefully you know, right? A little hint right here. We just need to call another delay. So we can create a new duration. This one is going to be const appearing duration is equal to duration. The milliseconds are going to be, hopefully you remember, 50 times the amount of frames, 7, which is 350, right? It's the same, which is good. And now we can do another future delayed. So future dot delayed, we're going to delay it by our appearing duration this time. And then we're going to pass in a new function and make sure you have the semicolon. Cool. So let's think of what we've done so far. Our player gets hit. It plays the hit animation. We then are now playing our spawning animation, our appearing animation, and setting our player to the starting position, offsetting it because it's the wrong size, and then setting our scale X to 1. Well, now we're in the right spot. So what do we want to do? Well, now we can just set our position. Well, I'll come back to that. I'll show you. Well, now what we can do is we can just go back to updating our player state. So we can do update player state because we don't know where we're at. We don't know where our starting position is. Our starting position could be in the air. If it's in the air, we want him to fall. If it's, on a ledge or anything like that. So what we can do right now, we're not able to call our update player state. So what we can do for one frame is we can just call our update player state, and it's going to actually update the player state. It's going to take us out of whatever animation we're in and put us in whatever animation we should be based on where we are in the game. So if we go over and hit this, boom, perfect. Now again, we have the same issue. I was about to fix it, but I wanted to show you why we have to fix it. Our player is being offset now by that vector 2 by 32. So we don't want that. So what we need to do is we need to do position is equal to starting position. Because before our position was their starting position with an offset of 32, now we just want it to be the actual starting position, which is perfect. And then if we go here and jump and get hit, there we go. Our player has now spawned, got hit, showed its hit animation, then showed its appearing animation, and then put us back to our starting spot. But there is a slight issue, and that is our player is falling because he was falling when we got hit. So we can fix this by just setting our velocity to equal 0. This way it's going to throw us at, hey, I don't know what your velocity is. The velocity is 0. So I'm going to just treat it as idle until I'm told otherwise, right? And then we can refresh this and save. And there we go. Now if we jump here, we're back. We're back. But we can't do anything. Why can't we move? My player has respawned, but I can't remove. And that's because, well, we can't move. We got hit. We still got hit, right? So what we need to do is we need to say got hit. Now that we've updated everything, got hit needs to be false, right? Because we got hit, we respawned, and now we're not hit anymore. We're good. Let's respawn. And now we can play. Now there is a slight issue. If I hold down, right there, if I hold down while I respawn, I'm going to start being able to move immediately. And that's not proper. So what we can do is instead of just calling got hit equals false, we can do one more delay. We'll call this const can move duration equals duration. And then this one, we can just make up whatever feels good. I think 400 is good. And then we can add one more delay here. So we can do future dot delayed can move duration, which I spelled wrong, duration. And then because this function is just one thing, we don't actually need any brackets. We can use an arrow function like so, and then just get got hit equals false. And then we don't need the semicolon because it's not in a thing. And let's get rid of this position that we commented out. So what we're saying here, and hopefully this makes perfect sense to you, when we hit our saw, what are we going to do? Well, we're going to say that we got hit. We're going to play our hit animation. We're then going to play our appearing animation. We're going to move our player to the starting position. We're going to wait a few moments and then let our player move, right? And now we don't get that weird janky thing that I'm trying to move when I can't move yet, because it does take a while. It does take a frame essentially for your player to be able to move after you've called got hit, right? Because it has to finish the code. So that's why, and again, it's going to take until the next frame for got hit to be considered false for us to be able to move anything. So I think that's a good way. The only thing I haven't tested, and I guess I can test it real time, if our starting position is in the air, I wonder what happens. That's the only thing I haven't tested. So let's test it real time. Yeah, our player isn't going to fall right away. So you could maybe change that, I guess. Let me know in the comments below how you think we should fix that. But that is because we are causing the delay for got hit. So if we don't have that delay, it should work good if he's in the air. It still has that slight freeze. So that might actually be, and I don't know. Let me know how you would fix this or how you think we should fix this, because that's the only thing. I figured that would be a problem, but that's fine. You know, it just respawns him. I don't know. Maybe you can put him off the map if he's going to be falling in the air, right? That's probably how you would do it. Think of Mario. Mario puts you in a spot that you can't even see, and then you fall down. So just if you don't know how to fix it, just avoid it. But there we go. We now have our saws moving vertically and horizontally. And if we hit them, which I didn't, but if we hit them, we respawn. And it works good. And even if we're going to the left or the right, it still respawns us in the best spot. I hope you guys enjoyed this video. This was a tough run, but definitely fun. The cool thing about, the coding is once you start coding it, we pretty much just did all the same. Futures were new. I actually learned that in this scenario because I wasn't sure how to delay stuff. But other than that, pretty much everything else we've already done, right? We've already know how to spawn stuff. We already know how to move stuff. We already know how to reposition stuff. So it's just a lot of muscle memory at this point. I'm hoping it's a lot of muscle memory for you guys as well. But I'll stop chatting now. In our next video, we're going to hopefully work on actually finishing the levels. We have obstacles. We have fruits. Now we can start finishing and going to the next level. So, and yeah, I hope you guys enjoyed this video. Subscribe if you're watching and haven't. I mean, obviously, hopefully you enjoyed it, and like the video, and I'll see you in the next one.